TRT is a joint venture between Rolls-Royce plc and Chromaloy UK. We specialise in the inspection, repair and overhaul of gas turbine components. TRT's motivation for this programme is to better understand how we can use digital technology to inspect components that we have traditionally done in a more manual way because of the requirements that are put on us by our end users. We believe there is opportunity that we can work with our partner, ADDQUAL, to understand better how we can use digital processes to make the right decisions at the right stage of our value chain to offer the best value for our end customer.
The project was about repair digital twins. This was taking information from the repair process and making that data available for engineers to make data-driven decisions. TRT are a partner and they worked with us on this particular project to allow us to demonstrate some of the ideas that we had. They acted as a platform, feedback, and allowed us to show what could be done and bring our ideas to life.
The challenges I face are having data to understand my process capability, which I currently don't have, and also having the right data to challenge the repair instruction. Another key part of this process really is being able to categorise repairs. So the parts come into us in very different positions. So the extreme could be that we've got a part that's flat and not distorted to a part that's completely distorted. If you try and fit those into the same process, the same repair process, clearly you're going to have problems. So the power of getting that data will be able to put the part into process number 1, process number 2 or process number 3, which again will increase the yield and the rework. So for me the two key outcomes of this project are really making our inspectors more efficient, so making sure that they use the digitalised data and not doing manual tasks, lots of manual tasks. And I guess the other thing is for me going forward is we're going to be able to get hold of really good live processing, in-process data to make decisions on improvements within the process.
We inspect these parts, the Trent 700 HPs, with hand tools, that is measuring hand tools. Before we receive them, they've gone through FPI to highlight any cracks so we can assess them to the engine manual. And also the thickness of the parts already been marked out for us so we can assess that to see if they're suitable for repair. We currently take probably a shift of 8 hours to fully inspect them, assess what's good, what isn't, and also to issue the paperwork for any non-repairable parts and also the repair routing to send the parts around the factory for repair.
To start with this project, the first thing was to understand why are we building this software. So it started by understanding the requirements, and this happened by engaging with the stakeholders to understand what the current process is and what an ideal solution would potentially look like. So this involved several workshops with different stakeholders, and then we identified what are the current loopholes, one of which was data gathering and data capture, which was missing. So I developed a data gathering map, identifying the data sources, the data types, and the key stakeholders who are responsible for them. And then I went to developing the software. Now the software factors in all of these stakeholders. There are different requirements in terms of what data type is actually important to them, and then it shows the processes from inception to the end, and then also captures key data points throughout the processes. And based on those data captured, they can understand what was actually happening throughout the process, and then they can actually see firsthand and then make data-driven decisions in real time.
When I came in here, so there were several challenges, and that includes a long queue of the parts that needs to go metrology scanning, and secondly there was a limited human resources and skill set to process those scanned parts. And the third one is that we need to meet the client deadlines. We have employed the robot that can handle the multiple parts. So we have a long queue of parts. So this robot can employ the pick and place application to solve this problem. Also we have developed an HMI system through which human can interact with the system, can work for 8 hours long without any human interventions. So the data-driven approach and strategy makes our system unique, and we are using this data to estimate the overall length of the scan and for how long we want to run the program. So our plan is to make this technology as a software as a service. We want this technology to be intelligent, efficient, and also autonomous by integrating some different sensors that can give us some important data that can be helpful for our stakeholders.
NATEP funding was really important for us. Being an SME, it's very difficult to fund these development projects. It also acts as a validation to the idea that we had in the first place. So it allowed us to invest in new people, new skills, and that knowledge then flowed into our business. We specialise in high value components, and data is the most important thing. What we realised was that we didn't have the skill sets, we didn't have the knowledge of how to scale these ideas and this information so it was more usable. So it was really important to apply for some funding or get some support from somewhere that would allow us to validate ideas, allow us to test developments, and allow us to demonstrate what could be done, what could be the state of art. The next steps in the project now are looking at how do we exploit the ideas that we've generated here and demonstrated. So step one, we'll be working with TRT to understand how do we take this forward and help them achieve more value from the projects. And the second step after that would then be looking at how we then do further developments downstream of the process. How do we capture more data and make it add more value for TRT?
So during this project, it's been great to see the interaction between TRT and ADDQUAL as the project has come to fruition. From TRT's perspective, they work in a very constrained environment being a repairer in the aerospace industry. So what this project has given them is the opportunity to build something which they could actually show to their customer and show it working. So it's really de-risked that process. And then from ADDQUAL's point of view, they've had resource to put the effort into this project. I mean, they've put about 8 man-years into the project, which is very significant. They've employed new people, new skills. They've got new technology which they can use going forward not only in conjunction with TRT but with other markets as well. So overall it's been hugely successful, and seeing this thing go from a series of post-it notes on a wall into fully fledged software and cobots and a functioning system has been great.